volume is 2.5 liters, 1.2 atmospheres, and 25 degrees Celsius. Moles is N. So if we rearrange this formula to find N, what's that? R is this constant. Pressure has to be in atmospheres. It is 1.20, so there's no conversion. Because of this label, volume's got to be in liters. In problem number 1, it is. And then temperature has got to be in Kelvin. It's not. So 25 plus 273 gives us 298. One point two times 2.5 divided by 298 divided by 0.0821. .123 moles.
What number is it?
Number 1.
Okay, question.
Yes, ma'am.
So it matters if it's in liters and it matters if it's in Kelvin?
Everything matters in this formula. You've got to match this label for R with all the other measurements. If they don't match, then you have to convert them.
But for that equation, it doesn't matter? The P1, V1 over T1?
That's right.
Okay.
The only thing that matters is temperature.
Okay.
It's got to be in Kelvin. Problem number 3 is typical for the way Metro can come at you, because you have to do a mass of conversions. In problem number 3, it says that you have 25 grams of carbon dioxide. It's at 25 degrees and it's 500 milliliters. What will be the pressure? My key to you is as you sit there and you say, okay, which formula do I use? The minute they mention anything about grams or moles, that's your formula. Yeah, okay, we'll go ahead and do it. Let's see, we want to find pressure. So pressure is equal to RT. I need to move volume over to the other side. It's being multiplied, so when we move it over here, it'll be divided.
So the Celsius needs to be in Kelvin and the milliliters need to be in liters?
And the gram has to be in moles. There's R. The next thing is N, and that's the number of moles. .25 grams of carbon dioxide. Grams, moles. 1 mole. Carbon dioxide is basically what, 4401? .32 plus 1201. Maybe you put your glasses on. I agree with you, 568. I'm gonna go a couple extra digits so I don't round off too much. So that's my number of moles. So now I've taken care of N. The next thing I gotta have is temperature. And in the story problem, it tells me it's 25 degrees. And R says temperature has got to be in Kelvin. So 298. And underneath is volume. And I have a volume of 500 milliliters. R dictates everything. R says it's got to be in liters. To get it from milliliters to liters, divide by 1,000. Metro likes a problem like this because they can check to see, can you convert in the metric system? Can you change grams into moles without asking you to do it? And then can you remember that temperature is in Kelvin? And the answer, the key says 27.8. Did that? .8 atmospheres. We don't have much time. We're gonna do one more problem because it's similar to what you're gonna do in the lab. I'm gonna take up a little bit of your lab time to help you with some things. Problem number 6 wants to know what the molar mass is. It said omit, but that's not for you guys. You don't get to omit anything. Let's see, a minute ago, the molar, I calculated the molar mass of carbon dioxide to be this. What's the label? What's the proper label for molar mass?
Amy.
No,
Gram.
not for molar mass.
Oh, gram.
Per
Mole.
mole. That label tells you what information you need to answer this question. Which one was it? This one. You need to know the grams that are caught and how many moles you have. And the minute they start talking about a gas, this is the formula to get moles. So we have, in problem number 6, we have 1.2 grams in 1 liter. So there's our mass, there's our volume. 740 millimeters of mercury, that's a pressure. And it's 20 degrees Celsius. I can use this value to get moles. One liter gets me my volume. R is a constant. Temperature in Kelvin will be what? 93. I gotta have pressure. And pressure has to be measured in atmospheres. And on one of the sheets that I gave you, you have it in the book, but in one of the sheets that I gave you that's stapled together there, I think on the back of the second one, it tells you that 1 atmosphere is equal to 760 millimeters of mercury. So we have to convert that into atmospheres. .745 millimeters of mercury. We want atmospheres, millimeters of mercury. What are the 2 numbers that make those 2 equal?
1 and 760.
1 and 760. If you'd be so kind as to divide 745 by 760.
0.026 if we're keeping.
Okay. All of these numbers are going to multiply and divide together to get us the number of moles. To 3 sig figs, what do you get for the number of moles?
1.7.
What's that?
1.79.
No. .79.
I got 0.
I like that. What's that?
I got 0.041.
0.04.
0.07.
07, okay.
I'm getting in the thousands.
I am too.
You're getting what?
In the thousands.
No. I'm sorry. We'll have to pick this up. We'll finish this problem down in lab. I've got to give up the room. 1 mole of any gas will occupy 22.4 liters. I don't have anywhere close to 22 liters, so I know I've got to have a small number.
I think we have to divide the bottom altogether